Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today we'll be talking to Dr. Peter Hairsine about sediment controls and the Great Barrier Reef. What are some of the greatest threats to the Great Barrier Reef today? Which land features pass on or capture sediment? What can we do? Answers to all these and more coming right up. I'm your host, Abby Morrison. Let's talk about science. Hi, Peter. Welcome to the show. How are you doing today?
I'm very well, thank you.
Excellent. I am so excited to get to talk to you today about one of my favorite ecosystems ever. But let's start off by learning a little bit more about you.
Well, I'm Australian, as you can probably tell by my accent, and I've spent over 30 years researching sediment and other pollutants moving around in the Australian landscape.
So we're going to be talking about the Great Barrier Reef today. Can you give us an overview of what that environment is like?
Okay, so the Great Barrier Reef is the world's largest coral reef. It's, to give you a sense, it's about 2,300 kilometres long and lies off the northeast coast of Australia. And it is impacted by a number of stressors. But one of the things that is a particular focus for me are the watersheds which drain to the Great Barrier Reef. So it's this connection between the land and the marine system, which is immediately off the coast. The Great Barrier Reef is a remarkable, diverse ecosystem. It's been described as one of the great wonders of the world. But in recent times, it's been under stress by a number of things. And one of those stresses is what we'll talk about today, is the reduced water quality, which is coming from the land.
Sure. And can you tell us a little bit more on a high level what that problem that you were looking into in this review is?
Well, the coastline of northeast of Australia is largely rural. There are some small towns, but the water quality which is coming down the rivers which drain towards the Great Barrier Reef has deteriorated over the last 200 years. And gradually that is having an impact upon the ecosystem. So my review really looks about the evidence around that link between the land and the marine system and formalises it. So there's lots of assumptions in the kind of popular media, but I test the weight of evidence by looking across the many peer-reviewed papers which have been written about that topic.
Awesome. So you looked at 3 areas of the reef in this review paper to see how we understood that they are being affected by some of these issues. Can you tell me a little bit about the 3 areas that you looked at and how you could tell that they were being affected?
Yes, thank you. So the Great Barrier Reef is this catch-all term for actually a kind of range of ecosystems. And those ecosystems stretch from the coast itself right into the deep water of the order of 200 kilometres offshore. So I have broadly divided those into 3 classes. The first is the seagrass beds. And seagrass is a little bit like native grass on the land surface, but the grass in the shallow water near the coast of northeast of Australia is a remarkably diverse ecosystem in itself. So it's very important in the life cycles of fish and is also the habitat of dugong, also called manatee in the world literature. So as a ecosystem which is close to the coast, the seagrass has been impacted by the pollutants coming from the land. The second system I call near shore reefs. So like many coral reef systems around the world, the Great Barrier Reef has some reef systems which are actually quite close to the shore, in some cases a few hundred metres, and in other cases in the very shallow water in the first few kilometres. These systems have evolved to be more tolerant to things that come from the land, because prior to any change to the land surface there was clearly still some things coming from the land washing down the rivers. And then the third system are the offshore systems, which I guess most people would consider the kind of classic coral reefs. They're characterised by very clear water for most of the time. They're very diverse systems, typically hundreds of species of fish, hundreds of species of coral, and a whole lot of other organisms that kind of interconnect with the coral. And those systems, because they are offshore, have historically not only had clear water, but had very low inputs. So some people describe them as nutrient deserts, meaning that they really get their nutrition at a very slow rate and recycle their nutrients within the coral reef system itself. So I've divided my review into those kind of three broad ecosystems.
Can you tell me a little bit more about some of the symptoms you see in these three areas that tell you there's a problem?
Okay, so it's worthwhile saying at the outset that water pollution from the land is not the only stressor which is impacting upon the Great Barrier Reef. So a recent analysis, which was published in one of the peak journals, suggested that the Great Barrier Reef was really being impacted by three current stressors or groups of stressors, and there's one further one looming with climate change. So I'll describe those and then describe the water quality one. So first of all, the sea temperature is warming, and that is the driver for coral bleaching, which is really just a breakdown of the way in which coral works and recycles its nutrients. So in recent decades, we've seen an increase in these bleaching events where the temperature gets high and coral struggle, then die. So in 2016, there was a major bleaching event in which 30% of the coral in the Great Barrier Reef died during that episode. So that's an absolutely unprecedented event. The second group of stresses is really around mechanical damage or storm damage, which is related to major storms which come in, which are a natural thing, but is being changed as the climate warms up. So, for instance, in the future, this is quite speculative, if the hurricanes which came onto that coast were more frequent or more severe, then that would have a greater impact than has previously happened. And the third group of stresses are really relating to the local impacts of what washes off the land and what's carried with them. So sediment is washed from the fields and from the ranches which are on the coastline, which are on the coastal watersheds, washes down the rivers during flood events, and carries with it a range of potential pollutants. So those mainly being nutrients and pesticides. And I must say that the nutrients are both fertiliser nutrients, but also the native nutrients, which have always been in the soil. So those are moving, but when I said those, the sediment, the nutrients, and of course the pesticides have increased in terms of their concentrations in the water that flows down the rivers and mixes with the ocean water. And they're having an impact upon the food webs which happen around the Great Barrier Reef, in the seagrass, in the near shore reefs and in the offshore reefs. So an example of that, and an important example, is that the life cycle of a particular starfish is such that it's gone from a normal part of the ecosystem to having increasingly frequent plagues where this starfish, its life cycle really gets out of control in terms of the balance between it starting life and growing and dying, and such that it gets into plague proportions and eats hundreds of kilometres of the coral. So there's a clear link now that's been established in many studies between the excess nutrients which is coming off the land and the life cycle of this particular starfish.
Yeah, I remember in middle school even watching a video in science class about the crown of thorns starfish, right? That's what they're called?
That's right.
Yeah, and I remember just watching sped up footage of mobs of them wiping things out. It was really, just really captured my attention at the time. So it's interesting to see how long this problem has kind of been around and apparently seems to be getting a little worse.
Well, that's right, Abby. And two things I would say around that is for people to kind of imagine how the crown of thorns starfish impacts the reef is that when it does get out of control, such that the normal controls are disturbed, then it's like a fire where the front of the fire goes across a forest, or in the same way, the front of the feeding adult starfish go across the reef. And really, normally, when we get to that stage, the control is that they run out of reef. So it is that devastating. Yes, the starfish problem has been around for some time. Certainly at the order of 20 years, it's been acknowledged that it's a problem and it's accelerating. What we now have is really an understanding of the mechanism and how that relates to what we do on the land. And the key thing here is that when the starfish are reproducing, normally what would happen is juvenile starfish would starve to death. There wouldn't be enough nutrient to support the little bugs in the water, the phytoplankton and the zooplankton that the juvenile starfish feed on. But because we have changed the water quality in the environment around the Barrier Reef, then as a consequence, those juvenile starfish survive and go on to an adult life where they can feed on the reef. So now we have an understanding of this link between everything that we do up on the land, the water quality, and then the life cycle of this particular problematic starfish.
Yeah, for sure. We'll include some links to some more information about those starfish. Maybe see if I can track down that footage. Who knows? But speaking of what we do on the land, I'm going to move us on to some of these sediment sources. So in your review paper, you looked at seven and a half, if you include the gullies as separate or not, different sources of sediment that impacts the reef. So we're going to do kind of a rapid fire. I'm going to tell you one of them, and you can tell me what they are, what they do, how they impact the water, and kind of any main issues that they might cause.
Great.
Awesome. So the first one is hill slopes.
Yes, so hill slope erosion is what many people perceive as soil erosion. So that's the problem where rainfall results in runoff on the land surface, and if not well protected by vegetation, in storm events, we have these high concentrations of sediment which are moving off, carrying the sediment, nutrients and pesticides. Now, in the Great Barrier Reef catchments, the evidence is that that's a significant source, but it's not the largest source of sediment moving to the coast. So that actually is quite a change in the thinking for a lot of people who've made that assumption over the years. Certainly there's some things that we need to do, conventional kind of soil conservation things, but it's not the only thing.
Sure. Next is foot slopes.
Foot slopes is kind of a bit of a catch-all term, but it's really to describe that part of the landscape which is at the base of hills where sediment normally accumulates. It acts as a buffer between the erosion that's occurring up on the hills and what sediment makes its way into the streams. So foot slopes can be managed somewhat separately to, if you like, provide that buffer. So the classic example of that is to maintain a grass buffer between hill slopes and the stream network. And that's been done for many years around the world. But of course, it's a contentious one because oftentimes these foot slopes, these lower parts of the landscapes, are highly productive land. So understandably, land managers are reluctant to take too much land out of production to provide this kind of buffer so that the water quality can improve.
Sure. Next, we've got two kinds of gullies.
Yes, that's right. So in the literature, there is quite a separation of two types of gullies, so it's worthwhile explaining those quickly. So conventional hill slope gullies are really extensions to the stream network. So prior to our management of the land, there was a stream network. Now that stream network has got longer as a consequence of land degradation which has occurred. This is especially so in landscapes which are drier and also where there has been dispersive soils form. So in the Great Barrier Reef catchments, there is around 80,000 kilometres of these gullies which have formed since the Europeans arrived in Australia 200 years ago. So that's a massive length of channel which is new and is yielding sediment itself. The second form of gullies is a lot less prevalent, but it tends to be very close to the major rivers and tends to yield a lot of sediment. So they're highly erosive, and they're called alluvial gullies. So the alluvial gullies, people can imagine them, they look a little bit like the Bryce Canyon landscape. They're a highly eroded, sculptured landscape, largely devoid of vegetation. And they form as a result of a combination, the settling of sediment over many tens of thousands of years on the edge of rivers, but also the chemistry that's occurring so that they become highly dispersive. And importantly, they're not driven by flow, they tend to just be driven by rainfall. And in the Great Barrier Reef catchments, we have a number of those. So they require special treatment. They tend to be areas that we simply fence off and try not to disturb at all, so they have no land use.
The fourth or fifth, depending on how you're counting the gullies, is going to be stream banks.
Okay, so stream banks are familiar to most people. They're the edge of the natural streams, and they're oftentimes environments that have tall vegetation on them naturally. And that tall vegetation provides stability so that the streams don't move around too much in the landscape. Now, if a stream is unstable, it means that it's eroding a lot of the outer banks. Also, there's deposition occurring in the channel, and that is a source of sediment to the rivers itself. And in the Great Barrier Reef catchments, we found that that's a very significant portion of the overall sediment that comes out of the rivers. So typically in the Great Barrier Reef catchments, in terms of sources of sediment, the stream banks are of the order of 30% of the sediment that we see leave the mouth of the rivers.
Wow. After that, we've got floodplains.
Yes, so floodplains are a feature of almost all the world's landscapes. So they're broad, flat areas adjacent to large rivers, and they formed as a result of sediment that's moved over many tens of thousands of years, being trapped in these kind of flatter parts of the landscape. In the Great Barrier Reef context, there are floodplains both in the middle parts of catchments, middle parts of watersheds, and also in the coastal strip. So you'll hear people refer to coastal floodplains. Historically, before the Europeans arrived, they were greatly reducing the amount of sediment that was moving down the rivers. But now that the sediment has increased as a consequence of man's activities, the floodplains have also stepped up, meaning that they trap a higher amount of sediment than they previously did. So the floodplains not only form a kind of a natural buffer, but they're something that we can work with to lessen the impact of upstream erosion sources.
Good on them. And then the next one is reservoirs.
Yes, reservoirs are clearly something which is geologically new. So, of course, in most of the world's landscapes, we use constructed reservoirs to store water. And one of the consequences of damming those rivers is that we also collect sediment. And for many, many years, we've known roughly how much sediment those reservoirs trap. So it's actually has quite a positive influence upon the pollutant movement down the rivers into systems like the Great Barrier Reef. So to give people a sense, a typical reservoir will trap between 80 and 90% of the fine sediment coming into the reservoir so that the water quality downstream is improved. And that effect is clearly a benefit to the overall budget. What it does mean is that the priorities for treating landscape is for the areas which don't have reservoirs present to do that buffering. So reservoirs are doing 80 to 90% of the job, and our focus can be centred upon rehabilitation works in landscapes that don't have those reservoirs present.
And what do you do with all of the sediment that gets stuck in a reservoir? Do they clean them out somehow, or what do they do?
That's very interesting, and clearly that's highly variable in terms of the amount of fine sediment which is moving around in the world. So interestingly, on a world scale, the Australian landscape, mainly because it's so dry, the amount of sediment which is moving down the rivers on a world scale is relatively low. And I think in a sense that explains why the Great Barrier Reef is there in the first place. Remember I said that reefs tend to like very low nutrient environments. Mm-hmm. So in the pre-European times, the Great Barrier Reef would have formed because it had low loading coming from the landscape. If you like, there was a trickle of nutrients coming from the land. And now, of course, that's accelerating. Elsewhere in the world, those fluxes are much larger, or those amounts are much larger. So, for instance, in the Chinese rivers, with its very silty landscape, the loads are huge, and it is a major design issue for reservoirs, the accumulation of sediment. So they've actually designed many of their reservoirs to be somewhat self-cleaning, so they can release pulses of flow from the base of the reservoir to manage that silt accumulation. In the Australian context, it's typically many hundreds to thousands of years before sediment accumulation becomes a design issue. So the accumulation of fine sediment in the bottom of a reservoir where it's very significant for water quality is not a significant design issue for the lifespan of the reservoir. And that effect varies greatly around the world, but it's not a design issue in the Great Barrier Reef.
Great. That's wonderful. The last one is estuaries.
Yes, that's right. So, of course, there's a transition between the fresh water coming down the rivers to the marine system. And estuaries around the world are quite dynamic environments where much of the load of sediment and things that it carries with it is deposited around the mouth of the river. That's why we have river deltas. That is one important buffer between the land and the marine systems like the Great Barrier Reef. The operation of those estuaries as a buffer, to understand them, has been subject to intense investigation. We typically, researchers will core or take sediment cores from those estuaries to look at how the material has accumulated and how that has changed over time in response to the increased loads coming down the rivers. It's another reason for those deltas to receive some degree of protection because of this functioning that they have in buffering the land from the reef system.
Hey everyone, I hope you're enjoying today's episode. Interested in learning more? Peter's review, Sediment-Related Controls on the Health of the Great Barrier Reef, is always freely available on our digital library. You can find a link to it in our show notes. Let's get back to the show. So for this review, you kind of looked at all of these different sources, parsed out which ones were more significant sources, and then you've looked to some of the strategies we can use to assist with those problems. So can you tell me about some of the solutions you talked about in your paper?
Yes, that's right, Abby. So what the review did was it assembled all of these components into an overall budget for the Great Barrier Reef and its watersheds as a system. In an overall sense, we have an understanding of the degree of connection between the sources of pollution, so things like gullies, hill slopes, stream banks, and the problem that we were focused upon, which was the deteriorating water quality around the Great Barrier Reef. So that budget enables you to look at not only what are the priority sources to control, but where they are. So there's a degree of spatialness. So an example of that is what I mentioned around the reservoirs, that because the reservoirs put in place this permanent buffer, then land which is upstream of those reservoirs is not as urgent to treat as, for instance, near coastal watersheds, which drain directly to the marine system. So we assembled that system and now can direct where rehabilitation should be invested in, and also the sorts of techniques. So because now through this budget, we also have a sense of which are the majority processes, and those are gullies, stream banks being the most important ones in these particular watersheds. We can prioritise things like rehabilitation of stream banks and some special treatments for gullies. So a lot of these are very rudimentary measures that we've known about for a long time, like simply putting a fence around gully networks, and also making sure that stream banks are managed as a separate unit, that we encourage the revegetation along stream banks, again by doing simple things like putting fences in place and providing alternative watering points for cattle. Those sorts of things clearly can have a benefit to the water quality within the stream network and ultimately to the marine system.
Can you summarize the major takeaway from analyzing all of these things? Like, what is the thing we most need to be doing to help with this on a large scale?
Yes, so, and this is a question which is quite central to the environment policy of both the state and the federal government in Australia. To give you an idea, so of the order of 600 to 700 million Australian dollars has been invested in this problem already, and there's ongoing programs to do exactly this. So I think the first takeaway is that there is a benefit to managing water quality coming from the land for the Great Barrier Reef. We can see a return in terms of protecting the reef and all the economy that's built around the reef by treating our land better. Secondly, the collected analysis points us to priority areas. Bearing in mind the watersheds of the Great Barrier Reef are about half the size of Texas. They're huge areas. So we need some spatial prioritisation as to where we best to invest that government money. I think thirdly, the collected research gives us some pointers to some techniques that can be used by land managers to actually manage their land to see that return. And that forms the basis of incentive schemes to make this happen. It's a long haul, it's a big problem that will take many years to address, but we need that evidential basis to make the scheme a success.
Speaking of that research side, I know doing this paper kind of identified some knowledge gaps that still exist and areas for future research. So could you tell us what some of those areas are?
Yes, so maybe two is worth focusing upon. The first one relates a lot to the kind of economics of change. So there's quite a knowledge gap about how long it would take in terms of time from treating the land to getting a response in the marine system. So in economic terms, this affects what's called the discount rate. So if, for instance, we were to do our rehabilitation today and we would see a response in the next wet season, so in Australian terms that's around Christmas time in the southern summer, then that's a very rapid response and gets more priority in terms of the benefits to the overall ecosystem and economy. But if this takes 2 or 3 decades to get a response because of the roles of the buffers and the lags in the ecosystem, then that would have a very different influence upon our prioritisation. So we need to have an understanding of this time lag between applying treatments on the land and the response in the marine system. The second knowledge gap that showed up is really the role of the floodplains. So we've known the operation of the floodplains as a unit, as I mentioned before, but what can we do to enhance their buffering role? Now, there's been some limited trials of this around the world, including some in Australia, but no specific research around that in these subtropical and tropical systems concerning the Great Barrier Reef. So there's a need to look at what can we do to manage the floodplains, whether it's strip cropping, whether it's reservation of that land, resuming that land, taking it out of production. We really don't know what the consequences are for the buffering effect of these key parts of land, which are the floodplains. So that's a priority area for future research.
Yeah. I've got 3 questions left for you. The first one is, if people would like to learn more about the Great Barrier Reef or any of these issues, where can they go to get more information?
Australia has an agency for managing the Great Barrier Reef. It's called the Great Barrier Reef Marine Park Authority, and they have a very good website, and much of the kind of state of the reef and understanding of the reef is kind of hung off that website. So I certainly would recommend searching for that. I should also mention that in terms of research, the marine system is addressed to a high degree by the Australian Institute of Marine Science. So that's another very, very good source.
Great. Second question is, if people would like to help with some of these issues, what can they do to get involved?
Yeah, so I think helping can extend to helping for your particular system. So there's the Great Barrier Reef, which clearly is an iconic ecosystem. There isn't enough being spent to address the issues that I've identified. So encouraging politicians in the Australian scene by the normal channels is very worthwhile. But these systems, or these problems, are present in all combined land marine systems, be they other tropical systems or less tropical systems. So looking at your own local connection between the land and what happens in the ocean is something that I encourage people to do. Just to understand those connections between the land and marine system is a very good start, and clearly there are many other systems that need lobbying of decision makers to make this more of a priority.
Sure, yeah, that's great advice. I'm actually going to ask you a bonus question before we get to the last question, just because I'm curious. Well, maybe 2 questions. Do you have a favorite animal or coral that lives in the reef? And do you go there often, or is this more from afar?
This is quite fascinating, Abby. So I guess when I talk to people about my work, a lot of them say, oh, you work around the Great Barrier Reef. You're very fortunate, to have that time, in the clear waters and seeing all these magnificent creatures. Well, most of my actual personal research is focused around ranches and cropping lands, which are on the land, which I also like. I'm a person who's brought up on farms. So to identify a kind of favourite marine animal is a difficult one for me, because most of my time is spent on the land, but I'll have a try. So in Australia, we have a creature that lives in the freshwater called a platypus, which I have been fortunate to see many times in my field work. It's a mammal that lives in freshwater streams, actually widely distributed on the east coast of Australia. It's unusual in that it's one of only 2 egg-laying mammals in the world, and it lives in the stream bank. So I guess that's a familiar one. It's an unusual one, but would be the closest to my favourite.
That's wonderful. Yeah, it kind of bridges the gap then for you between land and sea. So excellent choice. Yeah, they're smaller than I thought they were too. I always thought they were like medium-sized dog-sized, and they're not. I was very surprised.
Right, and they're quite timid, so you require a little bit of patience and a quiet day, often in the first few hours of the day or the last few hours to see.
That sounds wonderful. That sounds just like one of the best experiences you could have. So then final question is, what is one fun fact that people would not know about you as a person if all they had was your research?
Oh, that's interesting, Abby. So as a kind of professional researcher and having spent many, many years, in the business of doing research, investigations, experiments, building computer models, and then testing those computer models, you kind of can get a little disconnected from the land. So one unusual fact about myself is that when I went through my studies, I supported myself as a farm worker. So I worked to raise money to go to college. And that still forms a very important kind of reference in my life. That experience of, driving the tractor, building the fences, gives a kind of a sense of reality around many of the things which come out of research around this overarching issue of how do landscapes behave and how does land degradation impact upon the water quality in our streams and in coasts. So I think that's a very important balancing thing in my life to have had that experience, and I'm very grateful to the people who gave me that experience.
Yeah, that's really neat. I like that. Well, thank you so much for joining me on this call and for giving me some of your time. It's been really wonderful and insightful to talk to you.
Great, Abby, and I really appreciate your effort in putting this together.
Excellent. Thank you for listening to Field Lab Earth. You'll find a link to today's paper and other resources for this episode in our show notes or on our website. If you have any questions, comments, or recommendations for show topics, please contact us at podcast@sciencesocieties.org or on Twitter @FieldLabEarth. If you'd like to hear more content like this, please subscribe, and don't forget to rate and review us on iTunes or anywhere else you find your podcast if you like our show. This podcast is a joint production of the Tri-Societies, the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America. Special thanks to Lobo Loco for the use of their song Spook Castle on the intro and outro of our show. Opinions and conclusions expressed by authors are their own and are not considered as those of the American Society of Agronomy, Crop Science Society of America, Soil Science Society of America, its staff, its members, or its advertisers.